Welcome back, Power Property Pros. It's Justin again. It's the moment we've been practicing for. The final level of power play. Level 6, the final battle. Are you ready to harness the strength of multiplied might? Have you prepared to dive deep into the depths of division? Do you think you've got what it takes to conquer the variables and master the exponents? Do you dare to harness the power of the power? Can you tell I'm excited? We've been working so hard to learn all the exponent properties, and the time has finally arrived to put them to the test. It's time to simplify the unsimplifiable. Remember that property inventory sheet from the previous lesson's PDF? Make sure you've got that with you. And one last thing, there's a warm-up activity on the first page of your PDF for this lesson. Make sure you've completed that activity before watching the rest of this video. Pause here if you need to take a moment to find your property inventory sheet or complete the warm-up activity. Okay, ready? Here we go. Aliens? I didn't know there'd be aliens. We've got to simplify the expression 6k cubed times 4k to the power of -5. What's this scroll thing down here? Oh yeah, it's the property inventory tool we unlocked in level 5. This is definitely gonna come in handy. Make sure you have your property inventory sheet close by as well, so you can reference it even if this tool isn't open on screen. Before we start picking out properties and begin simplifying, it's generally a good idea to look over the problem so we have an idea of what's going on. Is there anything that stands out to you in this problem? I notice that there's constants, 6 and 4. There's variable components as well. Oh, and these have the same base. There's multiplication between all the components. And I notice a negative exponent too. Once you feel ready, it's time to jump in following the order of operations. There aren't any grouping symbols, so we can turn our attention to the exponents. Keep in mind, this lesson is all about simplifying expressions with exponents, so for this step of GEMS, we're looking for anything that would require the zero exponent property or any of the power of properties. Power of a power, power of a product, or power of a quotient. Do we need any of those to simplify here? Nope. So let's move on to M, multiplication and division. Is there any multiplication or division in this expression that would require either the product of powers or quotient of powers properties? Each element in this expression is multiplying, so we definitely have some simplifying to do now. Because all the components in this expression are being multiplied, you can add in those multiplication dots if you want. And if it helps you, you can rearrange the expression so that elements with like bases are next to each other. Pause here to combine the constants and the k elements. Six times 4 is 24. And according to the product of powers property, when two elements with the same base are multiplied, we can add the exponents. K cubed times k to the -5 becomes k to the power of 3 plus -5, or k to the power of -2. That takes care of the M in GEM, so all that's left is the S, subtraction and addition. There aren't any power properties used for subtraction and addition, and there's no subtraction or addition in this expression, so is the expression simplified? Well, in order to be simplified, the expression can only have positive exponents. So if we've already gone through all the steps of GEMS, when does the negative exponents property come in? The cool thing about the negative exponent property is that you can use it pretty much whenever you'd like.
When you use the negative exponent property, you're really just rewriting that element in a different but equivalent way. Some people like to start off with it to make some exponents positive right away. Others use it at the exponent step after the 0 and power of properties. And others prefer to use it at the end, like we did here. It doesn't really matter as long as you use it at the time that makes the most sense to you. Let's say we use the negative exponent property first when simplifying this expression. That would have caused this k to the negative fifth power to move to the denominator. 6 and 4 would still multiply to give us 24, but instead of the product of powers property, we would have used the quotient of powers property to subtract k's exponents. Either way, the final answer is still the same. Ready to find out if this simplified answer defeats the UFO? Only one way to know for sure.
It worked! Oh, here comes another one. This time we need to simplify 5m to the power of 7 n to the power of negative 4, all raised to the power of negative 1.
What stands out to you in this expression? I notice some negative exponents, a constant, 2 different variables, and this whole chunk is raised to a power. Try simplifying this one yourself. Take your time, follow gems, and use your property inventory sheet as needed. We'll check your work when you're done. First, simplify anything within grouping symbols. The only thing that could possibly be changed with these parentheses is n to the power of negative 4. If we want, we could go ahead and rewrite this element with a positive exponent in the denominator, but I noticed that this whole inner expression is raised to the power of negative 1, so I think I'm going to choose to wait to use the negative exponent property later once we see what happens with this outer exponent. Since I'm not choosing to use the negative exponent property just yet, we're ready to move on to the E in gems, exponents. Do you notice anything that requires the 0 or power of properties? Everything inside the parentheses is multiplying, so we can use the power of a product property and distribute this outer exponent of negative 1 to each element within the parentheses. Now that we're finished with the E step in gems and moving on to the M step, what do you think we should do now? All of these components are being multiplied, but their bases are different. That means there's nothing else we can do in the M step of gems. I also don't see any subtracting or adding for the S step, so are we done? No, we still need to do a little rearranging. Remember that negative exponent property that we can technically use anytime since it's just for rearranging and not an operation? Well, we need to use that property now to get rid of the negative exponents. 5 to the power of negative 1 and m to the power of negative 7 can be rewritten as their reciprocals with positive exponents. Then 5 to the power of 1 can be evaluated, giving us our final simplified answer. If you used the negative exponent property at the very beginning, your work may have looked something like this. Either way, both answers are the same.
Another UFO bites the dust. Oh, this is a big one. Here we go. The last problem of power play.
Take your time to look over the expression, follow the order of operations, and use your properties inventory sheet as needed. Starting with this grouping, x to the power of 0 can be simplified. The 0 exponent property tells us that anything raised to the power of 0 equals 1. Now these constants can be multiplied, making everything in the grouping simplified. On to the exponents step of gems, which means we're looking for anything that requires the 0 or power of properties. The power of a product property tells us that this outer exponent of 2 can be distributed to each element within the parentheses. Now, because we have a quotient, we actually need to jump back to the g of gems to make sure that the numerator and denominator groupings are fully simplified. This 4 squared can be evaluated, giving us 16y squared over 8y to the power of 6. Is the denominator grouping simplified? Yes, it is. So we're done with the grouping step. There's nothing that requires the 0 or power of properties, so we're done with the e step of gems too, which means now we can focus on the division. There's constants in both the numerator and denominator. Is there anything we can do with those? Both 16 and 8 are divisible by 8, so we can simplify them just like a fraction, leaving us with 2y squared over y to the power of 6. Finally, the y components have the same base and are dividing, so we can subtract the exponents. The component in the denominator has the larger exponent, making our final simplified expression 2 over y to the 4th. There is no subtraction or addition, so this expression is fully simplified. Here we go. The final UFO.
So I guess the answer's gotta be A.
Incorrect.
Wait, no, I misclicked, no! What's happening? Ah! Ah! Where am I? Am I in the game? Uh-oh. While you wrap up your guided notes and work on completing the PDF activity and online practice, I'm gonna try to find a way out. See you next time. I hope. I'm gonna check out what's over here.